All right, my plan for today, I want to go over last night's homework and then finish up the one that some of you wanted to turn in today. If you wanted any other extra questions on that, we'll go over today's homework, which was just 2 problems. There was a front and a back, but there was multiple parts to it. And then I will get you back your quiz that you took last week. We'll go over that. So coming out to you all is last night's homework, what you had submitted. So realize some of you might have turned in 2 sheets, so go through it if you turned in 2. Okay, so first thing, let's take a look at first page. It was 27-28 that I said if you wanted an extra day on, right? Mm-hmm. Was there anything on page 27 or 28 you wanted me to go over? Yeah. 13. Okay. So, Sam, number 13 was just like the 13 we did the day before. And you're looking at just where it's crossing the y-axis. So because it crosses at half, that a value has to be half on the g at x. Okay?
Why does it say find the value of k or a?
So on problem 14, they have a k value in there. So that's where it shifted down. So the asymptote changed. Anything else on that page 27, 28? Yeah.
15.
How much? 15? You got it. All right. Number 15. You might be, but some people didn't turn both in. Like, because I'm going over 27, 28, so some people might not have turned that in, so you might still have that. Okay. So compare the 2 functions, domain and range, and affected by the transformations. So if I have my xy axis here, I draw this, I plug a 0 in, that'll find me where it crosses the y-intercept. 2 to the 0 is 1. Then I go ahead and plug 1 in there. 2 to the first is 2. I have this as my intercept, or my asymptote. So that's what this line looks like. Go to this one, do the same thing. 0, 1, or 0, 3. And then, so if I plug 2 to the 0 is 1, 1 times 3 is.
Gotcha.
Flare off that a little bit. I'm not looking. Does it take the flare off it? That looks like. Okay, yeah.
11 and 12.
Yep. All right, let's see. Plug 1 in. 2 to the first is 2 times 3 is no. 2, that should be 6. Excuse me. So 1, 6 is like up here. So they both have a negative to positive infinity domain. All of them do. And then the range, as I go to the left, they are both approaching 0. As I go to the right, they're both approaching infinity in the y direction. So they have the exact same domain and range. Which one? B, 11 and 12? Brandon, 11 and 12?
Yeah, please.
All right. Number 11, we have this. F of x means the same thing as y, right?
Yep.
All right. So I'm going to plug 0 in to find where it crosses the y-axis. If I plug 0 in, I get half to the 0, which is 1, right? And then 1 times negative 6 is negative 6. That becomes negative 6. Negative 6 plus 3 is negative 3. That all right so far?
Yes.
Negative 3.
Oh, thank you. Oh, thank you. This one does have an asymptote at 3. Okay. Now let's plug 1 in and see what we get out of that. 1/2 to the first is 1/2. 1/2 times -6 is -3. -3 added to +3 is 0. So we go here. Let's graph this. Okay, and then it asks for describe the domain and range. Well, the domain, again, will always be negative to positive infinity. The range, as I'm going left, what number am I approaching? In the y direction.
I have a question.
Yeah, hang on. What number am I approaching?
First, I didn't see it come in.
Where am I going? If I go to the left, what y value am I approaching? 3. As I go to the right, where am I going in the y direction? Where? Negative infinity, good. Cool. Is that better having that blind down? Can you see the board a little bit more? Sorry, I was squinting a little too much up here, and I was next to it. Number 12? Yeah, we got.
So you had the 1, 0.
Uh-huh.
How did you get that?
Okay, if I plug 1 in, 1/2 to the first is 1/2. 1/2 times -6 is -3. -3 added to 3 is 0.
You put the 1 in front of there because. Oh, okay.
Oh, wait, did I go the wrong way?
I think you did.
I think it's supposed to go to the right.
Yeah.
Yeah, it was. 1, 0. Wait a minute. There it is. Okay, so this is wrong. That's incorrect. Thank you. So my range needs to change then. I'm sorry. So I came from negative infinity, and I'm approaching 3. That's not me. Someone's ringing. Oh. It's like, dude, what are you doing? What you doing in class? We're at the Dairy Queen. So I made a mistake on that one. I went the wrong way. I'm sorry. You always feeling strange. All right, number 12. G at x is equal to 2 to the x minus 4. So let's take a look at this. Let's plug 0 in first. 2 to the 0 is 1. 1 minus 4 is -3. Right? Huh? What? Plug 1 in. 2 to the first is 2. 2 minus 4 is -2. Let's see. We're going the right way now. 1, -2. Do I have a... Are you all right? 0 minus 3. Cool. What's my asymptote? Yeah, I have that -4, so down here. So this looks like this. All right, the domain is always going to be negative positive infinity. The range is going to be, so if I go to the left, I am approaching -4, so I'm coming from -4. As I go to the right, I'm going to infinity. That all right? How do we feel? All right. If you would, make sure your name is on that and pass that on forward, please. That was 27 and 28. And if you would, have 29 and 30 out on your desk. 29 and 30 out on your desk. We'll come by and mark it off. Have 29 and 30 out on your desk, please. 29:30 out on your desk, please. There is a whole stack of papers coming around. Please don't pass in graded papers to me. All right, so I'm looking for what page? 29:30. All right, thanks for reminding me. So have this on your desk, please. Page 29 and 30. I'm coming by and marking it off. Really confused before school, first period, fourth period.
Fourth period?
Actually, the last.
Third, fourth period off? Yes. Can I see you doing fourth period? Make sure you watch the video, okay? What? Six, watch my video. What did I do? Did I already mark yours? Did I already mark yours?
Yeah.
I'm here.
If you go onto my equation page, it will, you can print off a couple, go to the math science resource.
And that doesn't make any sense
All right. Do I have any more of the 27, 28s? Let's see, plug this back in. All right, 29 and 30, we'll just go through both. Is that okay? Take notes on it as you need. All right, problem number 29. We have f at x, that means the same thing as y. 4 raised to the 1/2 raised to the x. All right, so let's sketch the graph. So I'm looking for 2 points. Hey, real quick, what's the asymptote? What's the horizontal asymptote? It's 0, right? I don't have anything I'm adding to it, so it's got to be 0. Does that make sense? Is that all right so far? All right, from there, I'm going to go plug 0 in. 1/2 raised to the 0 power is 1. 1 times 4 is 4. If I plug 1 in, 1/2 raised to the first power is 1/2. 1/2 times 4 is 2. 1, comma, 2. So that's what this graph looks like. Is that growth or decay? Decay. As I head to the right, my graph approaches the asymptote. Make sense? Okay. All right, sketch graph. What is the y-intercept? What is the y-intercept? This is our y-intercept right here. Okay, that's my y-intercept right there. What is the equation of the horizontal asymptote? So this is 0, right? So the horizontal asymptote, that we'll indicate as HA, ha. Okay, horizontal asymptote is y equals 0. Y equals 0 is a horizontal line. Remember, y equals a number is horizontal. Now we want to start finding the rate of change on this, okay? So we want to find the letter D. We want to find the rate of change with -2 and -1. Okay, so what we'd have to do is we'd actually have to plug those points in to see. So if I plug this in, if I plug a negative into a fraction, what happens to the fraction? It flips. So if I take -2 and I plug it in here, this becomes 2 squared. Yes? 2 squared is 4. 4 times 4 is 16. Let me walk back through that in case you missed it. I'm taking -2 and I'll plug it in right here. If this is the -2 power, this flips this fraction over. So 1 over 2 switches to 2 over 1, which is 2. Then I get 2 to the second, because it's no longer negative, which is 4. 4 times 4 is 16. Same thing here. I'm plugging -1 in. If I plug -1 in, I get 1/2 to the -1 power. Flip the fraction, so it's 2 to the first. 2 to the first is 2. 2 times 4 is 8. Okay? So all we want to do right now, they're asking us, hey, what's the rate of change, the average rate of change? Means I'm finding the slope. Remember, the slope equation is this. Okay? So we're just going to plug it in. So just pick it. So 16 minus 8. 16 minus 8, -2 minus -1. So 16 minus 8 is 8. That's plus, that's over -1. So my average rate of change here is -8. Because it's a exponential growth or decay, the rate of change will change with your next set of points. So let's look at my next set of points. Bless you. We want -1 to 0. So this is letter E. So I want to go from -1 and 0. Okay, I already know what 0 is, 0, 4, right? Do I know what -1 is yet? Not yet. So 1/2 to the -1 power. Oh, wait, didn't I just find it right here? Okay, so I don't have to do that. Okay, so now let's find the slope. So I'm going to go 8 minus 4, -1, thank you, -1 minus 0. So that's going to be 4 over -1. So my average rate of change here is -4. See how the slope changed? Does it make sense that the slope changed? Yeah, because it's changing lines. And then letter F, rate of change from 1 to 2. So let's just spin this page a few. So letter F, we want to go 1 comma, I don't know, and 2 comma. Okay. So if I plugged 1 comma, I think that was one of the points I chose up there, so that's 1 comma 2. If I take 2 and plug it into my original, if I plug 2 in here, I get 1/2 to the second power, which is 1/2 times 1/2, which is 1/4. 1/4 of 4 is? 1/4 of 4 is? 1. Okay, let's find the slope here. 2 minus 1. 2 minus 1. 2 minus 1 and 1 minus 2. So I get 1 over -1. So the slope here is now -1. Notice our slope's changing. So it was, we started at -8, then -4, then -1. Okay. What do we notice about the rates of change? Okay. So let's think about this for a minute. If we're talking about the slope relates to something being linear, right? So let's talk about on this equation. So from -2 to 1, we had a -8 slope. Right? Down 8, right 1. So it's pretty steep. Then it gets to -4. So it goes from this to not as steep. Down 4, right 1. And then it goes to -1. Okay, it's not quite as steep. So as we progress to the right on our graph, our slope goes from pretty steep to almost horizontal. I say almost horizontal because remember this is going along the x-axis and it'll never touch it. All right. And then is f of x an exponential growth or decay? It is decay because as I go to the right, I approach my x-axis. I approach my asymptote. Good? Can I flip the page? Yay? Ready? Ooh, I gotta take a roll real quick while you guys are still. Move on to the back side, page 30. Page 30, this is number 2. I have f of x means the same thing as y. 3 to the x minus 4, right? Yay? Okay. Let's see. A couple of you are taking quiz there. You get it done? Did you get it done? Sweet. You're still working on yours? Yeah. Cool. All right. We need to graph it. Okay. Graph it. So I'm going to go 0, comma, blank. So 3 to the 0, 1. 1 minus 4, negative 3. Do I have a horizontal asymptote that's different than y equals 0? Yeah, what is it? Yeah, y equals negative 4, right? This right here. Is that all right? And then let's plug in 1. 3 to the first is 3. 3 minus 4 is negative 1. So I get 1, negative 1. So this is what this graph looks like. Okay. What is the y-intercept? The y-intercept is 0, negative 3. Which is that right there. What is the equation of the horizontal asymptote? The equation of my horizontal asymptote, which will indicate as HA or ha, is y equals negative 4. And then let's start finding rates of changes. All right, so rates of change, letter D. I want to know from negative 2, negative 1. Okay, so if I take negative 2 and plug it into my original equation, I get 3 to the negative 2. 3 to the negative 2 is 1 over 3 squared. 1 over 3 squared is 1 over 9. 1 over 9 minus 4 is negative 3 and 1/9, or 3 and 8/9. Is that right? Hang on. Borrow your calculator real quick. All right. 3 raised to the negative 2 minus 4. That's negative 35 over 9. If you leave it as a fraction. Is that okay? And then if I plug negative 1 in, that is 1/3 minus 4. It's negative 11/3. All right, ooh. I don't think this is a fair problem to give, so so if you were to find the slope of this, you're dealing with some fraction. So I'm not going to worry about something like that. That's ridiculous. I'd be doing. I mean, you're basically going to go negative 35/9 plus 11/3. The reason it's plus 11/3 is negative negative. do my fancy way, you get negative 105 plus 99 over 27. So I'm going to get negative 6 over 27, which reduces to negative 2. 2/9. Yikes. All right, pass them up. There's too many of you just chit-chatting. And then you'll ask me, oh, how do I do this? And then you turn around and start talking again. So pass them up.
With the quiz, I still have the last page.
Very good.
All right. I would like to do this. Period. So I'm going to hand back your quiz. I want you to keep your old quiz out. I want you to look at it. We're going to run through it fast. If you need, I don't have time to wait for you to say, oh, hang on, I'm still copying that down because I was talking to my neighbor while you were doing something. Okay? So list for your name. Come grab yours, please. You ready? So, guys and girls, please make any corrections. If you need to watch this video tonight, watch it. So problem number 1 is how you do it. 2 to the x times x to the 3rd. Like bases, so I get 2x to the 4th. Done. Number 2. Y to the 6, or y to the positive 6 times y to the negative 6. Like bases, I could add the exponent, so I would have accepted y to the 0 as an answer, but I was really looking for you to have 1. Okay, problem number 3. I have 3x to the 3rd, quantity squared. This comes here and here, so that gives me 9x to the 6th. 3 squared is 9. X to the 3rd to the 2nd is x to the 6th. Let's see, number 4. 2x y to the 4th squared. This distributes here, giving me 4. This distributes here, giving me x to the 2nd. This goes here, it gives me y to the 8th. That's my answer. Number 5. X to the negative 2 is 1 over x squared. Number 6. I'm just going to say, if I have a whole bunch of stuff raised to the 0 power, the answer is 1. I can't tell you how many of you continue to put 0 and you continue to get it wrong. Raise the biggest thing in the world you want to the 0 power, you get 1. It will never be 0. Yeah, but you're multiplying by 0. No, you're not. You're raising something to the 0 power. Making an exponent of 0 is not multiplying by 0. 7. I have 3x to the 5th, y to the negative 4. Okay, there's only one thing that needs to switch spots. Y to the 4th comes down. Number 8. I have 5a to the negative 3rd squared. This goes here. 5 squared, 25. This goes here. A to the negative 6. Not done yet because you have to move a to the 6 down. There's your answer. Am I doing okay on time? Number 9. I have a to the third, b to the fifth, c to the seventh, a to the negative 2, b to the negative 3, c to the fourth. Is that right? All right. This moves up. So how many a's are up on top? 5. 5. A to the fifth. This moves up. So how many b's are on top? 8. 8. These tug of war. Who wins? By how many?
3.
Done. Number 10. Over 10x squared divided by 3 z to the 8. Okay. First thing to worry about. 5 over 10 reduces to 1 over 2. Still with me? Tug of war with the x's. Who wins? Nobody. It's a tie. They cancel out. They're gone. I need to flip-flop the y's. So I have y to the third on top, y to the second on bottom. That's going to become tug of war in a minute. Tug of war with the z's. Who wins? Top or bottom? Bottom by how many?
2.
2. Okay. Tug of war with the y's. Who wins? Top or bottom? Top by how many? 1. Okay. So I'm going to get y over 2z squared. As far as the first page, we good? It is recorded. You can watch it.
Mr. Steph, are we going to get these types of questions on tomorrow's quiz?
Yeah, you will see some of these. It won't be, it's like 8 of them total, I think. Like, there's like 8 problems from this whole quiz, similar type, that'll be on tomorrow. All right, page 2, number 11, scientific notation. Ready? This comes here, this comes here. That gives me 81 times 10 to the 6th. Everyone good with that? It's not done yet. If you got to that point, you missed 1 point. Okay, the decimal's right here. I want to move it right here. So I want this to become 8.1 times 10. Okay? So this meant, if it was written like this, I'd go 0, 0, 0, 6 times. So now I'm going to have to move back 7. So that's 10 to the 7th. Okay, if you're having a hard time doing these, recognize that this was this. 1, 2, 3, 4, 5, 6 with the decimal right there. Move it back. 1, 2, 3, 4, 5, 6, 7. That's why it's a 7. Okay? Number 12. Back here, we're just going to extend it. Number 12, we have okay, so I'm going to go 6 times 8. I get 48. Still with me? Like bases, when adding, yes, it's a negative exponent. We can still go 3 plus negative 4. So that's times 10 to the negative 1. Still with me? Where's the decimal sitting right now? Yeah, it's right here. So I want it to go right here. So think about what this is if I rewrote it. It would be 4.8 times 10. Okay, now it's in proper form. So this transfers to 4.8. If I want to keep it as 4.8, 10 raised to what power won't change where the decimal is? 10 to the first is 10. Excuse me. It has to be 10 to the 0. 10 to the 0 is what? 1. 1 times 4.8, 4.8. Done. 13. 5 times 10 to the negative 3. 3 times 10 to the negative 8. Hey, brother. That's going to give me 15 times, like bases, just add them, so I get 10 to the negative 11. Think about what this means. The decimal's right here right now. This means I'm going to move this place 11 times. So I want to have my answer as 1.5 times 10 to the negative 10. Okay? So I've moved one decimal over. Goes to that. 14. 2 times 10 to the third over 10 times 10 to the negative 5. 2 over 10 is the same thing as 1 over 5. 1 over 5 is the same thing as 0.2. Agree? I would think about moving this one up. So then I have times 10 to the 8th. Okay, so this means move the decimal over 8 spots. So I want the decimal here. So I moved it over 1 spot, so it's now to the 7th. There's your decimal right here. Good? 15. 15. Root 27. This breaks down to 9 times 3. That's going to give me 3 root 3, because that's my perfect square. 16. Square root of 49 equals 7. I will tell you about half of my students told me that the square root of 49 is equal to the square root of 7. I hate to tell you this, but you're wrong. Take the square root of a perfect square, you just get the number out, right? No, I thought you had to leave the square root. No. 17. Root 8 times root 8. Same thing as saying root 64. Root 64 is 8. Done. It's perfect square. Number 18. 2 root 3 times root 3 is 2 root 9. What's 2 root 9? Root 9 is 3. That has an answer of 6. 19. 2 root 12. That's the same thing as saying 4 times 3. Square root of 4 is 2. So I get 2 times 2 root 3, which is 4 root 3. Number 20. 2 root 5 squared. That comes here. That gives me 4. That comes here. That gives me root 25. Root 25 is 5. So I get 4 times 5. 20 is my answer. That's the second page. Got 5 minutes to get this last page. We good? And move on? It is recorded, so please watch. 21. Square root 25, x squared, y to the 6th. This whole thing's a perfect square. Square root of 25 is 5. Square root of x squared is x. Square root of x to the 6th. Divide it in half is y to the 3rd. Done. Moving on. 22. I get root 8, 8y, root 2y to the 3rd. Let's combine. I get 16y to the 8th, all under a radical. Okay? This is a perfect square. Square root of 16 is 4. Square root of y to the 8th, divided in half, is y to the 4th. Root 6 plus root that. There's a 1 right here. Agree? So I get 4 root 6. Done. 24. 2 root 36 plus 3 root 81. Square root of 36 is 6. That gives me 12. Plus square root of 81 is 9. That gives me 27. So that gives me an answer of 39. 2 root 3 times negative 3 root 15. 2 times negative 3 is negative 6. Root 3 times root 15 is root 45. I could break root 45 up into 9 times 5. Square root of 9 is 3. So this gives me an answer of negative 18 root 5. 26. 5 root 40 minus 3 root 90. Let's break 40 into 4 times 10. 5 and 8 won't work because they need a perfect square. 90 is 9 and 10. Okay, square root of 4 is 2, so this is going to become 10 root 10. Agree? Square root of 9 is 3, that becomes 9 root 10. 10 root 10 minus 9 root 10 is 1 root 10, so you can have that as an answer, or you can have this as an answer. Doesn't matter which one. 27. 14 over root 2. Can't have a radical in the denominator. Multiply top and bottom by root 2, root 2. On top I get 14 root 2. On bottom I get root 2 times root 2, which is root 4. Root 4 is 2. This fraction reduces. So I get 7 root 2 over 1, or just 7 root 2. 28. Okay, this is going to break into this. Nice thing is the top becomes this. But I need to multiply top and bottom by this and this. Don't pack up yet. Come on. I get 2 root 5. Root 5 times root 5 is root 25, yes? Root 25 is what? 5. You want to see the extra credits? Come see me. Guys and girls, I would strongly encourage you to take a look at this. Also, your homework for tonight. We'll have the quiz is not quite as long tomorrow, but the homework for tonight is page 31 and page 32. Please recognize the difference between a linear function and one that's exponential. Okay? That'll help you quite a bit on this. Other than that, that's all I got for you.